Okay, well, the scene looks pretty cool, but I'm not quite sure. Gliding on a magic carpet or broomstick. So today we're going to be looking at a somewhat obscure repository that I think gives us some insight into the future of AI generated games, or AI/gaming, the combination of the two, which a lot of folks like myself are probably interested in. So this is by Tencent Arc, who I do believe you may or may not be familiar with. I think Arc is just like a research portion of Tencent. Don't quote me on that. But this is called AnimeGamer, and it is an infinite anime life simulation with next game state prediction, as we can see right here on the screen. So really, this is kind of hard to understand, and it was kind of a pain to get working and installed, but it will work on a single 24 gigabyte card, and it does show a lot of cool future directional kind of examples of how this technology can progress into actually using AI to make generative games and things of that sort. So what this is, I think the best way is to just kind of show an example. So simply, we can see right here that you interact with a dynamic game world through open-ended language instructions. It generates consistent multi-turn game states consisting of dynamic animation shots, videos with contextual consistency. Now, before we go further, I want to make it clear that this isn't going to pop up a game window on my screen where I can then just enter a prompt and then the game character will go ahead and do that. It will eventually lead to something like that, but for now, this is kind of what we're restricted to. So as I open my text editor right here, we have this demo.txt file, and there are some basically scene instructions here, or game instructions. We can see we have our character defined, and you'll have to excuse me because I know nothing about anime, so I don't know if I'm pronouncing these names right or whatever, but we have the character Kui, and then we have a motion as well as a background defined. So each of these will actually cause this whole model or architecture to generate a video clip, and the whole idea here is that eventually you can have an infinitely going game where you basically just enter a new prompt in and then the character will go and do that. This is kind of an early example from it, but I did actually go ahead and run this. The results get saved into a video subfolder right here, and each of these little videos corresponds to each one of these lines. So this instruction right here would perhaps be video n_3. Let's just go from first to third because these are supposed to be a little funnier and these are not the default examples that come with it. So the first should be casually sipping on bubble tea, and the background should be a day sky. Okay, I don't see bubble tea there, but the background looks good. I've noticed when you actually play with this and you try to have it generate things that may not be in its training data or actions like that, it doesn't do as well. But notice that the backgrounds are actually generated pretty well. So this is supposed to be munching on quirky snacks with the background as a day countryside. Let's try the third, which is supposed to be playfully shooting a water gun. All right, that is not at all correct, but the background there does look pretty good. And if you know stuff about anime, you can perhaps comment on whether or not the graphical style of these generations is fitting of this specific anime or not. Flopping onto a picnic blanket with a smile. I had ChatGPT generate these, so it's... okay, well, the scene looks pretty cool, but I'm not quite sure. Gliding on a magic carpet or broomstick. Okay, I see a broomstick there, and the cloud is moving with a wink. Yeah, we're not getting a wink there. Let's try. We're just going to sequentially go through these. Okay, which one is this? Balancing a broom like a dance partner, background night street. Well, the background certainly did show up well. Then we have... Oh, perhaps I don't know. There's two more. We'll just click on them. Okay, that is a null result. Ooh, that's actually quite cool. All right, well, I don't really know which one this is supposed to correlate with, but it is quite neat. So basically, it's hard to demonstrate this repository because it seems like it is pivoted or poised to be so much more than what we see right there, which essentially looks like a text-to-video prompt strung together. But this actually, when you start looking behind the hood and more into what the direction of their actual kind of purpose and point of this repository, it gives us insight into some of the future directions that we will see with generative AI powered or enabled gaming. So for this repository and for this kind of video, what we're going to do is basically go through this a little surface level. We'll take a little look at the actual research paper behind it because that actually gives us some good insight into the direction of this and what it is supposed to represent and how it differs from just a simple text to video thing like that. And then finally, we'll actually just run some generation examples. It does take a very long time to generate those separate video clips, but there are some optimizations and things like that we can do to speed it up at the expense of quality. And then finally, I'm not going to do a total setup and install process for this because quite frankly, this was kind of a nightmare to get installed and working, but I will just throw out some tips and things like that. Essentially, as a TLDR for perhaps a verbose explanation, this creates a continuous controllable game state based off of previously generated frames and things of that sort to keep consistency throughout shots and provide perhaps a baseline for the ability to play an infinitely generated game, where in this case you just control the actual characters, the situations they're in, and what they do just using text prompts. So the hang-up, and I won't say the hang-up, but the issue I see with this right now is that it takes an extremely long time to actually go ahead and generate each of these into a video clip, and then we basically just then go ahead and independently have to watch each video clip. So consider this to be a very early demonstration of where this technology is going to be heading in the future. And that is part of the reason that I wanted to do this video, but I was hesitant because it's not my typical video where here's what it is, here's how we install it, then let's do some testing. This is just something really cool that I found that I basically want to show people because I think others will have interest in this as well. So with that out of the way, let's basically just go ahead and actually change some of these prompts, and we're going to see a bit of differentiating things. Now in this repository, and again, I don't know anything about anime, but they talk about two different characters. So they have Sosuke from Ponyo on the Cliff, and then Kwikwi. Again, I'm probably not pronouncing these properly, but basically we can actually go ahead and change this to actually refer to the other character, so the Sosuke, which I will go ahead and just do right now. So with these all changed, it will now actually go ahead and generate based off the data set that it has for this Ponyo on the Cliff. So this character right here, instead of the one we first saw, which was Kwikwi or whatever. So once we do this, we do need to just change a couple of other things. So once that is all correct and set up, we can essentially go ahead and actually follow along with the repository right here, where we talk about to generate action-aware multimodal representations and update the character states. We first run Python inference underscore mllm.py, which I will go ahead and do right here in my setup conda environment for this and everything like that. And this happens much quicker than the next step. Let me go ahead and shrink this browser window right here. And once that has been completed, our next and lengthy process is to actually go ahead and run inference decoder.py, which is to decode the representations into animation shots. We can run this. So as we do this right now, essentially what's going to happen is it's going to take what it generated right here, and it is then going to decode these representations into animation shots. And this will also be referencing, of course, the actual demo.txt file that we modified right here to have our characters Sosuke or Sosuke, I don't know, in these specific scenarios and situations. So it'll be interesting just to see. It is going to take a bit of a long time to actually get this done. You will see the card load here on card 0 begin to jump up very high, as well as the actual power draw, and the terminal will kind of just update with the steps it's working on, and eventually when it is finished we will be able to go back into the same videos folder that we were in right here, and we will see the videos that are newly generated referencing our new game demo text file. Our generation has finished, and I didn't count specifically, but I'd say that was somewhere between 9 or 10 minutes most likely. However, sometimes my estimates are widely off the mark, so take that with a grain of salt. Let's just open up right here quickly once more our demo.txt file, which basically shows the script for our game scenario, if you will. And we can see first, okay, so we have Sosuke, casually sipping bubble tea, background, day sky. And you have to remember, these are actions that are likely not actually reflected in the training data for this model, like sipping bubble tea. So again, they're probably not going to be perfect. Okay, so that's our, again, for the anime fans in the audience, please let me know if the graphical styles here are good. Munching on quirky snacks, background, day, countryside. All right. Our next is going to be playfully shooting a water gun, background of Daytown. That's it's quite disturbing. All right. The next is flopping onto a picnic blanket with a smile. Oh no, this is the side eye. I apologize. Giving a dramatic side eye with the background of a Daytown. Okay, so it seems to not be doing great right here. Let's just go through them a bit quicker. All right, this one is also quite concerning. Let's check 6. All right. It does seem like perhaps we kind of lost the mark a bit here. All right, let's just check the last one. Oh, okay. That was dramatically reclining onto a cozy beanbag, background night. Well, it did get the background night, but I've noticed if you have the background set as anything dark like a night street, it really struggles seemingly with that. So again, this is not a plug and play solution for a game scenario. However, really the interesting thing here, and again, I can't just read it all on camera without just being a horribly boring and verbose video, but in the actual research paper here, they really do kind of give the directional understanding of what this represents in terms of perhaps future looking AI game generation. So I've totally figured that this was worth covering, even if it's not so interesting to look at now, just because of what it represents as kind of a stepping stone up the stairs or ladder of AI and game generation, which I know a lot of folks, like I said, are interested in, as am I. So really, I'm not going to give a full kind of in-depth install instruction tutorial, but I will give a few tips for some of the issues that I kind of encountered. So as we're looking at this right now, and keep in mind that this may change as the time from when this video was posted grows further, but what I ended up having to do is go into the pull requests right here. And we see there's one right here that basically talks about just fixing a bunch of things, pointing to the right cog video X repository, which this one doesn't, adding in some dependencies that were not there and things of that sort. Basically, I went to the actual repository for where this pull request stems from, and I followed along doing everything here, and we can actually see that there are a few additional instructions here for actually downloading the required dependencies and things that it relies on. What I am going to say that gave me the most struggle is essentially if we go into the actual directory right here where it is all cloned, there is a checkpoints folder. Now, something I struggled with, and here I'm showing this because I just kind of want to give a visual representation of what your checkpoints folder could look like as well if you do decide to do this. One thing that kind of messed me up was here, if we go into cog video and we go into the T5XXL, the actual shards here were not the actual files, it was just the pointers to the files, so I manually downloaded those and then placed them in here, which resolved some of my issues. In addition to that, as we saw in my text thing right here, there are actually some configuration files and things like that that go along in this repository. So if we go back here, go into MLLM and configs, we can see if we go into CLM models, these configuration files actually exist in here. Now, fortunately, we can probably ignore the one for Mistral, but right here you can see that there is a pre-trained model path, and I just had to kind of change this to reflect my specific directory. Some of them I tried with the actual, the term is eluding me right now, but the full path for it, so the static like hard-coded path, this is a relative path, so it's just saying checkpoints MLM so souk. So you have to change this depending on which character you want to actually use for the generation. There is also some other things here in the cog video one where there is the model directory. So this is just hard coded the entire path, as I was having problems with these checkpoints, but I did fix that. So you probably could just use a relative path here as well. And there was also another one right here. So these are just things to make note of, that if you do try to install this and you're encountering issues, definitely check all of the actual locations of where this is looking for these specific model files and things like that, because unfortunately the repository as it sits is likely not going to work. If you just try doing this and then try doing this, you're going to get a lot of kind of issues. So I would just say go into the pull requests here, and then from the actual repository linked in the pull request right there, start there, and then just kind of follow some of these things and make sure all your clone files are properly placed in the actual locations and they're not just pointers to the actual file, because then you'll get errors and things like that. And then make sure that your configs are set. So there are configs in the MLLM folder as well as in the VDM decoder, and we can see that's where the Cog Video X one is also, but there's also one here for inference, and you will see that you need to also load the path for the VDM decoder. And again, this is just a hard-coded one. I was kind of flip-flopping back and forth trying to troubleshoot things, and these you can likely leave okay, as I haven't touched any of the output directories or things like that. And yeah, so I did just kind of want to, I'm going to leave that. I did just want to quickly touch upon and show this repository, as I think it's very interesting. Even if right now it's not necessarily cool to play with, it is a glimpse into the future. And ever since I did the AI generated CSGO, I've been really wanting to cover things that are more related to generative AI in gaming as well. So this is kind of another foray into that special area for myself and hopefully those who are also interested. That is likely going to wrap up today's video. If you have any questions, please don't hesitate to leave them in the comments. I will do my best to kind of try to help you troubleshoot if you're encountering some errors and trying to get this running. And aside from that, thanks for watching.